Hi everyone, so I'm Game Vids here with a new video for you guys. Today we're going to be taking a look at AMD's Computex presentation. I have edited it to make it much shorter than the actual presentation so you can get the important announcements. Let me know what you guys think. Leave your comments and questions below. And be sure to like, comment, and subscribe. Thank you so much and enjoy watching.
Good morning, Taipei. It is absolutely wonderful to be here in Taipei, opening up the Computex press conference. And I have to really thank the entire Computex committee, particularly Taitra and TCA, for inviting AMD to our first ever keynote here at Computex. Our big bets are around high-performance leadership. And high-performance leadership is not one or two things. It's really a series of decisions that were made 3 to 5 years ago that position us for this year in 2019. And if you take a look at some of those bets, the first is in process technology. We've chosen to be at the leading edge of process technology. We want the best that the industry has to offer, and frankly, that's in 2019, that's 7-nanometer process technology, and we are extremely proud of partnering with TSMC because they do have the best technology in the industry. The second bet is around high-performance cores. The cores are really the engines of our products, and you want those engines to be as modern and capable as possible. And so today, we're going to talk to you about our Zen 2 cores, and we're going to talk to you about our Navi products. And that gives you an idea of our high-performance engines that will power the next decade. All right, so look, the data center is really incredibly exciting. And what's exciting about it is the data center really helps us solve the world's toughest and most important challenges. And when you think about some of the most important scientific problems in the world, or you think about high-performance computing, or you think about the tremendous growth in the cloud, or all of the focus on machine learning, all of these things need lots and lots of computing horsepower. And that's what it is we've been focused on. 2 years ago, we introduced the Epyc processor family. Epyc was meant to really bring a new era in the data center. We wanted to change the rules. We wanted to allow people to use single socket or dual socket systems, depending on their workloads. And with that, we have seen tremendous adoption in Epyc over the last 2 years. Today, we have more than 60 AMD Epyc platforms in production. And if you look globally at the largest cloud environments, many of them are using AMD, including Microsoft Azure, including Amazon, including Baidu, Tencent, and many, many more. We have more than 50 AMD Epyc cloud instances in production right now. But I talked to you about solving the world's toughest problems, and it's actually something that we're very proud of. We're engineers. We like to solve problems. And just a few weeks ago, we were very, very honored to be selected for probably one of the most challenging, if not the most challenging supercomputer in the world. AMD was selected by Oak Ridge National Laboratories and the US Department of Energy, together with Cray, to build a 1.5 exaflop supercomputer. That's 1.5 exaflops. It's using a future generation of AMD Epyc, and it's using a future generation of our AMD Radeon Instinct. And the reason we love it is because we know it's going to be incredibly challenging, but our goal in 2021 is to have the world's fastest supercomputer on AMD technology. So with that, let me bring you to our first announcement of the morning. You saw what we could do in supercomputing capabilities, and what we're announcing today with Microsoft is we are bringing that supercomputing capability of scale into the Azure cloud. And the idea here is that we have the ability to have the largest cluster of Epyc CPUs, over 10,000 CPUs, that will really allow you to simulate very, very large tasks. And our first customer has already said that they have been able to get over 7,500 times speed up by using the Azure cloud with Epyc compared to what they could do before. So I think that's pretty amazing, huh? Now, I also want to give you an update on our second generation Epyc processor, Rome. Rome is an incredible product. It's built on 7nm technology. It's up to 64 Zen 2 cores. It has incredible compute and I/O and bandwidth capability because of the way we architected this device. And when you look at what that means, what we see in our labs and in our customers' labs is we see up to twice the performance, 2x of performance per socket compared to our previous generation. And on floating point workloads, we see up to 4x because of the floating point capability that we've put into Rome. All right. How many of you love Radeon? We love Radeon. And what we say is Radeon is really everywhere. So if you think about it, today, there are over 400 million gamers that game on Radeon. Over 400 million. And when you look across the PC form factor, notebooks, Apple iMac, MacBook Pro products, when you look across the game consoles with Sony and Microsoft, and most recently, you saw Google announce that they're starting their cloud gaming technologies using AMD, you really get the sense that Radeon is everywhere. And one of the things I say, and I say very, very often, is AMD just loves gamers. So, Navi is our new family of Radeon GPUs, and it is really built to power the future of gaming. And when you think about Navi, think about it's really the start of an incredible future in gaming going forward. So, let me tell you a little bit about Navi. Not many people know much about Navi. When you look at Navi, we believe that it can power a tremendous number of applications. Just last month, Sony announced the first application of Navi. They announced that their next generation PlayStation is going to be powered by AMD with our semi-custom portfolio using Navi as well as our Zen 2 products. And Navi has an all-new 7nm RDNA architecture, Radeon DNA. This is different from GCN, and I'm going to talk more about why it's different and what it does for us. Navi is also focused on gaming. Like I said, responsiveness, performance, and so faster clock speeds, higher gaming performance, lower power. And Navi is also the world's first gaming GPU that has PCI Express Gen 4 enabled. So let me tell you a little bit about our DNA. And again, we call this Radeon DNA, so the R has a red Radeon here. The way to think about it is AMD has had a long history of architectures in the GPU space. We love GCN. GCN has been a great architecture for us. And frankly, you're going to continue to see GCN as we go with new versions of Vega and many of the high compute workload applications. But you guys know how we thought about Zen in CPUs. When we designed Zen in CPUs, we decided it was time for from-scratch design, because we believed that you needed a new design for the future. And that's exactly what RDNA is. RDNA is a gaming engine, the architecture that will power the foundation of gaming for the next decade. So we're extremely excited about RDNA. RDNA is significant new capabilities. It's a brand new compute unit design. And the idea here is to optimize that compute unit for the future of gaming. And it's really focused on efficiency and increasing the number of instructions we could do per clock. We also have an all-new cache hierarchy. And that's all about making gaming more responsive, reducing the latency, getting higher bandwidth, getting lower power, doing more. And the third point is we streamlined the graphics engine. And this is really bringing the architecture together and optimizing for performance per clock as well as higher clock speed. What we see is 1.25x performance per clock. So the way to think about this is that's architectural efficiency. Every clock cycle, you get more performance because of those compute engines and how we've optimized the pipeline. And then when you put that together, both the architecture, the design capability, as well as the process technology, we're seeing 1.5x or higher performance per watt capability on the new Navi products as a result of RDNA. I want to introduce the Radeon RX 5000 family. And the RX 5000 family actually is named in honor of AMD's 50th birthday. So 50 is the year that we start the new architecture RDNA. So let me introduce you to the first Navi GPU. Thank you, Scott. Seven-nanometer architecture, RDNA, RX 5000. And some of you may say, this chip actually looks pretty small. We like it small. It's small, but it has incredible performance in it. All right, Scott, what are we going to show our fans here?
Yeah, hey, look, I'm super excited to show the world today Navi running for the very first time a real live gaming demo and benchmark. And on behalf of all the AMD engineers that have worked on the Navi product family, we are super excited to get this in the hands of gamers very, very soon. So behind me, you'll see that Chris over there has already started the benchmark running. This is Strange Brigade. It's running on 2 GPUs. On your left is the RTX 2070. And on the right on the screen is our brand new Radeon RX 5700 series GPUs. Strange Brigade is a co-op third-person shooter game. It's designed to play with your friends. You can fight minotaurs, fight some scorpions, also solve puzzles and blow stuff up, which is my favorite part. I love blowing stuff up. And then you can see as the benchmark comes to a close here, you'll see the scores right behind me shortly. This is what I'm extremely proud of our engineering team. You'll see that on average, the RX 5700 GPU beats our competition by roughly 10% performance in this very early edition of the game demo. So I'm super excited about that. Thank you. Well, it's going to be very soon. So we will be launching everywhere in the world at retail and e-tail, available in July. And so I'm very excited for that. So maybe I'll also tell everybody, if you want to learn more about Navi, for all the gamers on the stream and here in the audience, you can come and either watch it on stream live, or if you're at the E3 trade show on June 10th, 3 p.m. Pacific, we will be talking about all the good details, including price points, performance, products, plural, and also all the new features inside of RDNA, all the technical features that we're putting into games, and excited to announce today some exclusive game content from our game partners up on stage with us, Lisa, to celebrate our Navi launch, and it's going to be a really fun time come June 10th.
Fantastic. Thank you so much. So let me start with a little bit about what you know. You know, third generation Ryzen is based on 7 nanometer Zen 2 cores. This is part of our Zen processor family, and it's the third incarnation of our Zen processor family. You also know that it's an AM4 socket, and that's important because we wanted our enthusiast fans to have the continuity of AM4. And it's also the world's first PCIe Gen 4 platform, and you're going to see that in action today as well. So now let me tell you some things you may not know. Let's start first with the core. The core truly is the engine of our third-gen Ryzen, and Zen 2 is an incredible core. When you take a look at some of the features, we doubled the floating point. And why is that important? Doubling the floating point in PC applications means you have faster performance in creative workloads for all of those content creators who want to do more. We also doubled the cache size. Why did we double the cache size? Because access to memory is so important. And we believed that if you reduce the memory latencies, you get much, much better performance, particularly in games and how gaming performance works. And then the most important piece of Zen 2 is the IPC, or the instructions per clock. IPC, you work incredibly hard for every single percentage of performance. And when we started Zen 2, our engineers told me, Lisa, I think we might get 8 to 10% IPC. Zen was a great core. Zen is a great core. We think 8 to 10% is reasonable. But my engineers are amazing, and they always surprise me and us. And so today, I'm happy to share with you that Zen 2 in the PC workloads actually achieves 15% IPC uplift. 15%, every percent counts. And the reason it counts is because IPC lifts all boats. All applications improve with IPC, whether you're talking about gaming or heavily threaded applications and so on and so forth. So we're really, really happy with how Zen 2 has come about. But I'm sure you guys want to know what the product can do. Is that right? Yeah. All right, so let's start with the very first third-gen Ryzen product. It's the Ryzen 7 3700X. The 3700X is the world's first 7-nanometer desktop CPU. It has 8 cores, 16 threads, 4.4 gigahertz boost frequency, 36 megabytes of total cache, and all in an amazing 65 watts of TDP. $65 watts for 8 cores and 16 threads. That's the power of 7-nanometer technology. If you take a look at some of the performance characteristics, look, the second-gen Ryzen is a great set of products, but what we're seeing with the 3700X is significant double-digit performance in both single-threaded and multi-threaded workloads at that significantly lower power. So more performance, lower power, third-gen capability. But with that, you probably want to see the third-gen in action. So Robert, come on out and help me demonstrate 3700X.
I can do that. Hey.
All right, Robert, what are we going to show?
So we've got Cinebench R20 running, and I was thinking back to my time as a reviewer looking at AMD's K7 and K8 architectures, a long time ago. And we've used Cinebench for over 15 years to reliably and quickly test the performance of a processor. And now we're on Cinebench R20, which came out just last month. And what you'll see on your right is the Ryzen 7 3700X versus, on the left, the Core i7 9700K. And as we churn through this realistic, ray-traced scene, you may notice that the Ryzen 7 3700X is quite a bit faster. In fact, it's about 1/3 faster than the competing part. And that's really a testament to the compute performance of Zen 2 and the density that the 7-nanometer Zen 2 architecture brings to a chip.
Fantastic.
And it's just a monster performance. And I think if content creators really, really want something special, that's just 65 watts. This is a beautiful, beautiful part.
So we love 3700X, but you know we love processors in general. So let me introduce you to the next member of the Ryzen 7 family, the Ryzen 7 3800X. The 3800X is now the 8-core device for the enthusiast gamer. The boost clock goes up to 4.5 gigahertz, 36 megabytes of total cache, and you see this is now at 105 watts. And when we think about the 3800X, we really think about it as the 8-core performance leader. So take a look at the improvements. Ryzen was always an incredible processor, but when you look at the gaming improvements that we've been able to get with 3rd Gen Ryzen, you can just look generationally. These are some of the most popular esports titles, things like League of Legends, Dota, PUBG, and you can see tremendous double-digit performance improvement, because we really believe gaming performance is critical, and we designed the 3800X for gaming performance. So with that, let me invite Robert out again to show you what 3800X does.
Okay, so this time we have the Core i9 9900K on the left versus our beautiful Ryzen 7 3800X. Both of them 8 cores, 16 threads. And the great thing about it is this beautiful PUBG demo that we built and recorded to reliably test the performance of this game. This is a tough game to benchmark, but we've done it. And what you'll see is that both processors are about the same. And in fact, that's ideal. I know as a gamer that I want a processor that gives so much performance to the GPU that it's out of the way. I don't even have to worry about the fact that my GPU is being bottlenecked by the processor. So the Ryzen 7 3800X, if you are looking for a chip that gives you the performance you need for those high-end GPUs, this is it. It's the best game in town. And if you add in all the other technologies, Lisa, like Gen 4 and 7 nanometer, it's the only choice.
So what we want to show you next, Robert's going to help me. We're going to show you the 3800X with the new Navi Radeon RX 5700 series, with X570 motherboard, and with a tremendous amount of I/O capability using PCI Express Gen 4. So this is actually the world's first PCI Express Gen 4 ready gaming PC and demo. So Robert, let's show our crowd.
Absolutely. So we built 2 systems. On your left, a PCI Gen 3 system, and on your right, exclusively and uniquely from AMD, a PCI Gen 4 system. And this is running the upcoming 3D Mark PCI Express feature test, which is designed to answer the question, how much extra graphics performance can you get from PCI Gen 4 versus Gen 3? And the answer is clear, and it's large. Up to 69% more performance for graphics from having PCI Gen 4, which you can only get from AMD.
Just take a look at that bandwidth.
So we're running about 25 frames per second on the AMD system and about 14 frames per second on the Intel system. And this is just a really great demonstration of what Gen 4 can do for gamers, and you think about how that might help games in the future.
The AMD is pushing gaming beyond 8 cores, and today I am so proud to introduce the new AMD Ryzen 9 family. So for the very first time, take a look at AMD Ryzen 9. Is this beautiful or what? When I showed this at CES, many on the internet wondered, because I had 1 core chiplet, whether we had room for the 2nd core chiplet. And the answer is we absolutely have room, and this enables us to bring Ryzen 9 to the market. So, I love silicon. But I also love products and showing products off. So let me talk about Ryzen 9. The Ryzen 9 3900X is the absolutely first mainstream desktop processor with 12 cores and 24 threads. And what you see that's so special here is this is the no compromise product. We have 4.6 gigahertz boost, 70 megabytes of total cache, and it's all in 105 watts. And when we say no compromise, we mean that it is a phenomenal multi-threaded CPU, but it's a phenomenal gaming CPU as well. So with that, let me invite Robert back to show off the performance of our 3900X. Robert?
All right. For my last and final trick, I'm going to take socket AM4, AMD socket AM4, against Intel's HEDT socket. This is a $1,200 processor on the left versus the AMD Ryzen 9 3900X on your right. And we're running Blender, which is trusted by many content creators to evaluate 3D rendering performance. And it's just a really great content creation tool. And what you see from every box is a processing thread. And as we come to the finish, the difference is clear. We finished in about 32 seconds versus the competitor's 38 seconds. And that's about an 18% performance improvement for AMD. And we're going core to core, 12 versus 12, which means Zen 2 is simply faster.
Fantastic.
Yeah.
Woo! Our competition is at 165 watts, and we are at 105 watts. Does that look great or what? So I know it all looks great, but I know now you're wondering, how much does this cost? When am I going to be able to get 3rd Gen Ryzen? So now let's go there. At AMD, we believe in bringing the best technology to our fans and to our ecosystem, and that's the way we think about it. 3rd Gen Ryzen is amazing. When you look at the 3700X, when you look at more performance, lower power, all of that versus our competition, what we believe is the price point for an entry-level 8-core device should be $329. And when you move up to the 3800X, the ultimate 8-core 16-thread device for gamers and content creators, incredible performance, both single and multi-threaded, we also believe, again, we want as many people to have this as possible. So this will retail for $399. And finally, the Ryzen 9 family. We love this guy. We love this guy because we love that we can bring something to the market that nobody has ever done before. In 12 cores, 24 threads, you saw, Robert, we compared against our competition whose device is more than $1,100. But we believe that we want as many people as possible to have the Ryzen 9 3900X. So when this goes on sale, it will retail for $499. That's half the price. That's half the price of our competition with much, much more performance. So now you want to know when you can get this all. And when you put all this together, what you see is the AM4 platform has been amazing. Just take a look at what we have done over the last 2 years. When we started the 1st Gen Ryzen, we thought it was amazing. But in just a little over 2 years, we have brought the performance at the $499 price point up 32% single-threaded, double in multi-threaded performance, and increased the core count from 8 to 12 cores. At AMD, we call that innovation, and I hope you see this is what technology leadership is all about. So now you want to know when you can get 3rd generation Ryzen. I am very, very proud to tell you that all of these processors go on shelf on July 7th. First 7-nanometer desktop CPU on 7/7 for all of you.